Let's do a game mechanic where when you click, the ball will travel towards the place where you clicked. Right now, I've got my x speed and y speed set to 0 initially, and I'm drawing the ellipse. And if the x speed and y speed had actual numbers in them that were not 0, I'd be moving the object. And then these two lines of code are about bouncing off the walls. So let's go ahead and start. I think it would be nice to say if the mouse is being pressed. So we'd actually written if mouse pressed is true. Then let's draw a line from the xy coordinates of the ball to the xy coordinates where the mouse is. And the reason that seems nice to me is just because then you can kind of see the trajectory for where you're going to launch it. And I want it so that when I release the mouse, that's when the ball actually moves. So we did this one time, but you might not have remembered it. Here I am outside of the draw method. So notice there's the curly brace, the closing one. So underneath that, I'm going to say public void mouse released. You have to spell the word released correctly here, and you've got to make sure that it's a capital R, otherwise this built-in method won't work. But this method will run automatically whenever you were holding down the mouse button and then you let go of it. So what I want to do is I want to set my x speed and y speed to a new value. And I want to figure out what value will send the ball in the direction of the mouse. So if I look at the difference in the x coordinates, so if I start with mouse x and I subtract the x coordinate of the ball, that's going to set my speed to be the direction that the ball needs to move in to get to the mouse. This is going to end up being way too fast, but let me just illustrate. Same thing for the y coordinates. So again, I'm saying like get the difference between the two coordinates, and the order I subtracted them in ensures that if the ball is to the left of the mouse, for example, that means that this x coordinate will be smaller than the mouse's x coordinate. So that means that, wait, what am I trying to say here? Let's just do it. Sorry, it's easy to think about when you have a picture, but hard to think about if you're just doing it abstractly. So you saw it moved super, super fast. A very easy solution to this is let's divide it by a value that will slow the speed down. And we want the speed to get slowed down by the same amount in the x direction and the y direction. So now I select and I let go, and there we go. It's moving towards the mouse, and it just keeps bouncing. So that's a kind of a nice mechanic. Let's add a couple of things to that. If you wanted to combine this with gravity, you could totally do that just by adding the code that we already looked at for gravity up here. Instead of that, I think what I want to do is I want to add something that acts like friction. So every single time step, I want to have the y speed decrease by some amount. So here I'm saying take the y speed and set it to be 97% of what it used to be. And that's happening 30 times a second. So the net effect here is going to be that the speed just decreases over time. Oh, I need to have f here. F means float. So count this number as a floating point number rather than a double. Okay, so I'm not sure if I have the actual right value for a good-looking friction here, but we'll soon find out. That's not so bad. It's a little bit strong, isn't it? So you can like fiddle around with that. Let's make it quite low, actually. Oops. Okay, so now, oh, what's happened? Oh, sorry, I went in the wrong direction. So I said make it 90% of its old value. Really, I want it to be like 99% of its old value. So I'm only reducing the energy a very small amount on every step. Yeah, it's not so bad. I hope that